This lesson is on remainder and factor theorems. This is section 2.3 from your book. So if we had the function f of x equals x squared plus 5x minus 4, and we had a 0 at x plus 2, we could factor out that x plus 2 and get f of x equals x plus 2 times q of x, where that q of x is equal to, obviously if we divided both sides by x plus 2 in order to get q of x by itself, we would have x squared plus 5x minus 4, that whole thing divided by this x plus 2. It's a different way to write that q of x. So if we want to divide by x plus 2 to find out what else we had left in that equation, maybe where we have other zeros, that's what we would get. We would get x squared plus 5x minus 4 divided by x plus 2. So from the equation above, q of x could also be described as q of x equals f of x, just our generic f of x divided by x plus 2. And obviously we can't have x equal to negative 2 because this would make our q of x undefined. So we can solve for q of x with long division, which is hairy and maybe not the most fun, but you all know how to do that. So I wrote this x squared plus 5x minus 4, and that is our dividend. Then we have our divisor, which is our x plus 2, so that's what we're dividing by. Our dividend is what we're starting with. And we're going to end up with some quotient. We're going to end up with some solution up here. So let's do this. How do we divide x plus 2 into x squared plus 5x minus 4? So I'm going to take that x plus 2 and I'm going to go into this first part. So we're just going to look at x squared plus 5x. How many times does x plus 2 go into x squared plus 5x? And we want to get rid of that first term in order to move down the line. So we're going to say that this goes into x squared plus 5x x times. If we multiply x by x, we get x squared. If we multiply x by 2, we get 2x. So we're going to subtract that solution. That's how we do long division, if you remember. So we have minus x squared and plus 2x, but we're subtracting this whole thing. So essentially you have negative x squared and negative 2x. So you're subtracting x squared plus 2x from x squared plus 5x, and you end up with, the x squareds are going to cancel out, and you're going to have this negative 2x plus 5x essentially, which is 3x. Then we know the next thing you do is you bring down that next term, so we have minus 4, and we want to know how many times does x plus 2 go into 3x minus 4. Again, if you remember, we want to get rid of that first term, so we are going to say that x plus 2 goes into 3x minus 4 3 times. That's going to give us 3x, and x times 2 is going, 3 times 2 is going to be 6. Again, we're subtracting this whole thing, so you might make each of these negatives if you want. That 3x goes away, and we end up with negative 4 minus 6, which is going to give us negative 10. We're out of terms, so we know that that negative 10 is equal to our remainder. So we have remainder negative 10. And our quotient is x plus 3 with remainder negative 10. So what does this mean? What is this x plus 3 remainder negative 10? What are we left with? Well, we know that this negative 10 is going to be divided by x plus 2, because essentially that's actually what we have left. And this equation that we have is really f of x divided by some d of x, right? This is d of x, which we're calling our divisor. You could also write this as f of x over x plus 2 is equal to x plus 3 plus negative 10 over x plus 2, because you have to also deal with that remainder. You can't just leave it alone. So if we go back to the original equation, we could multiply both sides by x plus 2, and we would end up getting f of x equals, if we wanted to get f of x by itself, the way we would do that is to multiply by x plus 2. So you're multiplying this whole thing by x plus 2. So you have x plus 2 times x plus 3, and then this x plus 2 and x plus 2 cancels out. So you have x plus 2 times x plus 3 minus 10. There's another way that we can divide polynomials. So synthetic division is a shortcut for dividing a polynomial by some other polynomial x minus c. So this first one, we had x plus 2. We write it in x minus c, so x plus 2 compared to x minus c, then our c is equal to negative 2 for that first situation. So to use synthetic division, the best thing to do is have a coefficient of x that is equal to 1. So whatever you're dividing by, this x plus 2, your coefficient of x should be equal to 1. And your power of x should also be equal to 1. So we don't want to really try synthetic division yet with x squared or anything like that. The procedure for synthetic division is to first rewrite with all the missing powers. So if you're given x to the 5th plus 3x squared plus 4, you want to rewrite this as x to the 5th plus 0x to the 4th, because we didn't have that x to the 4th in there before. We want to fill in all the gaps. Then we also don't have a third, so we're going to write 0x to the 3rd, plus we do have that 3x squared. We are still missing an x, so that's 0x plus 4. This is 0x essentially to the 1. So any locations where you were missing your x from the original equation, you want to fill those in. You want to rewrite this with some zeros. That way we can do synthetic division. The next thing you do is you remove all the x's, so you're left with just the exponents. So this would be, once it's in order, 1, 0, 0, 3, 0, 4. Which looks like some crazy code. I promise this will work out. So then you're going to bring down the first coefficient. I'll show you how that works. Multiply by c, multiply c by that coefficient, and then place under coefficient 2. So let's do an example to work this out. I think that'll be a little bit more clear. So we start with the example, divide 5x cubed plus 6x plus 8 by x plus 1. So we have x plus 1 as our divisor. We have 5x cubed plus 6x plus 8 as our dividend. And we want to first write this with all the missing powers. So we have x cubed, x, and 8. So we're missing x squared. We need to put it in order too. So now we have 5x cubed plus 0x squared plus 6x plus 8. And we want to know what our c is equal to, right? We're going to be dividing by some c, so we need to figure out what c is. We know the equation is x minus c. We're given an x plus 1. So x plus 1 is going to equal our x minus c, and in this case, our c would then have to be -1. So we're doing synthetic division with -1. So what you do is you put that -1 up here, the top left, right next to all of your terms. And our terms that we have, because we filled in all those terms, and the next step we did was to get rid of the x's, is 5, 0, 6, 8, because we had 5x cubed, 0x squared, 6x, and 8. So we have -1 on the outside, 5, 0, 6, 8 on the inside. The first thing we're going to do is bring that 5 down. You don't do anything to that 5, you just bring it right down. So we have that -1 on the top left, we have this 5 on the bottom. The next step, and this is really important, is you're going to multiply that c by this first term. So you're going to say -1 times 5, and then you're going to write this, whatever this result is, underneath your second term. So we have this, we just have two lines. We have 5, 0, 6, 8 on the top, and then we have another line under that. So we're going to say, I'm sorry, I guess there's 3 lines because you brought that 5 all the way down. So we have -5 is our result of 5 times -1. And the next step we're going to do is add. So instead of just bringing that 0 straight down, like we brought the 5 straight down, we're going to say 0 plus -5. So whatever we got for that first term, we're going to say 0 plus that thing. This ends up being -5. Then we're going to repeat that step we did before. So we had -1 times our term. Now we're on the second term. So -1 times -5. You put that result right here. So that result goes under the 6, under our third term. So now we have 6 plus 5, because that was our result, and we get 11. Let's do it again. We're going to do -1 times 11. Put that result over here where we have -11. Then we're going to add, so we have 8 plus -11, because we don't just bring that 8 down, we have to add it to whatever that product was. So 8 plus -11 is going to be -3. That -3 we have on the outside of another line, because this is actually a remainder, this last term. So we can, this can be written as a polynomial. Must be 1 degree less than the original equation, obviously, right? We had some x cubed divided by some x. We're going to end up with an x squared. So that's our very first term, is going to be 1 less than whatever we started with. And so we're going to write this as whatever we have on the bottom here. If you'll notice, these are the same. So we have 5x squared. That's the first thing we brought down. And then negative 5x, so minus 5x, because we had 0 plus a negative 5. And then we have plus 11. That's the last thing. We had 6 plus 5. But we still had that remainder negative 3 to worry about. And if we remember what we have to do, we still have to divide this by x plus 1, because this whole equation is essentially f of x divided by x plus 1. So with that remainder, you divide by that x plus 1. You could also rewrite this by multiplying x plus 1 to both sides, and you'd end up with an f of x. So let's talk about remainder theorem really quickly. So synthetic division can also be used to evaluate a function by examining the remainder. What does evaluate mean? If we remember that, if we had some f of x equals x squared plus 1, and we wanted to evaluate that function at f of 2, at x equals 2, all we do is we plug in that 2 where we had an x. That's what we're talking about when we're saying evaluate. So if a polynomial is divided by x minus c, this is your remainder theorem right here. If a polynomial is divided by x minus c, the remainder r is equal to f of c. So we had f of c up here equals 2, plugging all that stuff in. You can also find it when you use synthetic division and you end up with a remainder. That's also equal to your f of c. So let's do an example. So given f of x equals 5x cubed plus 6x plus 8, evaluate f of x for x equals negative 1, first using substitution and then using synthetic division. This is going to let us know if we're doing it right, if we understand this procedure. So if we wanted to evaluate 5x cubed plus 6x plus 8 at f of x equals, for x equals negative 1, then we are going to plug in that negative 1 wherever we had an x. We had an x here, we had an x here, we're plugging in that negative 1. Then all you do is you simplify, right? So we have f of negative 1 equals 5 times negative 1 plus 6 times negative 1 plus 8. You end up with f of negative 1 equals 3. So per the remainder theorem, we could have also done synthetic division for negative 1. So that's going to be our c. Our c is going to be negative 1. So we can put this c over here where we put our c last time, on the very top on the left, and we have negative 1, and then we rewrite that polynomial with everything filled in. So we had 5x cubed plus 6x plus 8, so we know we need to take care of that 0x squared, so we have 5, 0, 6, 8. Per synthetic division, the first thing we do is just bring down that 5, so that 5 comes down to the very first term. The next thing we do is we multiply negative 1 times 5, and we get negative 5. Again, we're going to add these together. We get 0 minus 5 equals negative 5 right here. Then this is the thing you're going to multiply by with that c. So now we have negative 1 times negative 5. We move this negative 5 up here, we have 5 under our 6. We add 6 plus 5 together, we get 11. The next step we do is multiply negative 1 times 11. We get negative 11. And when you add these together, you get 8 plus negative 11 equals negative 3. So what do we notice? F of negative 1, when we used remainder theorem with synthetic division, we got f of negative 1 equals 3 because our remainder was 3. When we used substitution, we have f of negative 1 also equals 3. So this checks out. We know we did it right. So this is a good technique for using when you have higher numbers or higher exponents. I think it's a bit quicker because all you're doing is a quick multiplication and a quick add. So another quick example, we're going to talk about the factor theorem. A polynomial f of x has a factor x minus c. We can have that factored out if and only if f of c equals 0. So if we have no remainder, if our remainder equals 0. So let's do some examples and use the factor theorem to determine if the binomials given are a factor of f of x. So we have some binomials, x minus 1 and x plus 3, that we're going to compare, and we're going to try to find if those are factors of this big crazy equation. So we start with 4x to the 4th plus 21x cubed plus 25x squared minus 5x plus 3. So we can rewrite this on this term using synthetic division. So we put 4, 21, 25, negative 5, and 3. We have x minus 1, so our c is a positive 1. We work this out, we bring the 4 down, we get 4, multiply 4 times 1, you get 4, move that on the second line, add that, so 21 plus 4 is equal to 25. 1 times 25 is equal to 25. 25 plus 25 is 50. 1 times 50 is equal to 50. Negative 5 plus 50 is equal to 45. 1 times 45 is 45. 3 plus 45 is 48. So our remainder is not equal to 0. Our remainder is not 0. That means, no, x minus 1 is not a factor of that original f of x. So for x plus 3, we have our c is equal to negative 3. Bring the 4 down, that's our first thing we do. Then we have negative 3 times 4, we get negative 12. 21 minus 12 is equal to 9. Negative 3 times 9 is equal to negative 27. Then we have 25 plus negative 27, we get a negative 2. Negative 2 times negative 3 is equal to positive 6. Negative 5 plus 6 is equal to 1. 1 times negative 3 is equal to negative 3. 3 minus 3 equals 0. So yes, there's a remainder of 0, which means x plus 3 is a factor. So that also tells you that we have a 0 at negative 3. So this is a really helpful way to find that out.